I am B. Janardhan Reddy. In this video, I am going to show you a lab activity pertaining to Ohm's law. Ohm's law states the relation between the potential difference across the two ends of a conductor and current passing through it. That is, it explains the relation between V and I. Okay. Now here is the aim of this lab activity. The aim of this lab activity is to show that the ratio V by I is constant for a conductor. Here V means potential difference, I means current. Okay, so for a given conductor, the ratio V by I is constant. That we have to show in this lab activity. Okay, and materials required in doing this lab activity is 5 dry cells of 1.5 volts each, conducting wires, an ammeter, voltmeter, thin iron spoke of length 10 centimeters, and key. Here I am showing you the materials required. So these are the dry cells of 1.5 volts each. So I have taken 5 dry cells, and these are the conducting wires. Next, this is an ammeter. An ammeter is a device which is used to measure current in a circuit in amperes. Okay. Similarly, here is a voltmeter which measures the potential difference across the two ends of a conductor in volts. Okay. And this one is the iron rod, isn't it? 10 centimeter length. And this is a tap key or key. So these are the materials required in order to do the lab activity pertaining to Ohm's law. Here I am connecting a circuit. So this is the dry cell. I am taking only one cell initially. This is the positive terminal, and here is the negative terminal. At the bottom we have the negative terminal, at the top we have the positive terminal, and this one is the ammeter. Ammeter also has two terminals. The black one shows negative knob or negative terminal. The red one shows positive knob or positive terminal. So we have to connect the negative terminal of the battery to this negative knob here. Next, and the positive terminal of the battery has been connected through the iron spoke, and the second end of the iron spoke has been connected to the positive terminal of the ammeter through key. And here key is opened, and when the key is opened, current will not pass through the circuit. When it is closed, some current passes through the circuit. That means some current passes through the iron spoke. When current passes through this iron spoke, some potential difference will get developed across its two ends. In order to measure the potential difference across the two ends of this iron spoke, we have to connect a voltmeter in parallel to this. Remember, ammeter should always be connected in series, whereas voltmeter should always be connected in parallel to the conductor across which we have to measure the potential difference. So here I am connecting voltmeter. So the voltmeter has been connected parallel to this iron spoke. Ammeter is in series. Okay, so ammeter measures how much current is passing through the iron spoke, and because of that current passing through the iron spoke, some voltage will be developed across the two ends. That voltage will be measured by voltmeter. So every time we have to note down the voltmeter reading and ammeter reading, and we have to tabulate all these readings in a table. Okay, see here, now I am closing the key. Now, so how much current is passing here? 0.1234, 0.4 amperes current is passing through the iron spoke, and here 1, 1.2, 1.4, 1.5 volts potential difference has been developed across the resistor here. So V equal to 1.5 volts and I equal to 0.4 amperes. Let us note down these readings in a table. So this is the table, serial number, potential difference V, current I, and V by I. I will calculate V by I later. First serial number 1. So the potential difference we got 1.5 volts. The potential difference across the iron spoke I am talking about, and current passing through it is 0.4 amperes. Okay. Next, this time I am going to use two dry cells. See here, two dry cells I am using here. These two dry cells have been connected in series. That means here I am increasing potential difference. When potential difference is increased, what happens then? More current will flow. So that means every time I will increase the current passing through the iron spoke, then I will measure the current as well as voltage. See here, the same way I am connecting. This is the negative terminal is connected to the negative terminal of the ammeter, and positive terminal I will connect to the iron spoke. Okay, now let us close the key. Again we have to measure ammeter reading and voltmeter reading. How much current passes through the iron spoke and how much voltage will get developed across the iron spoke, across the two ends of the iron spoke. I am closing this. See here. So here how much current is passing through the iron spoke means 0.1, 2, 0.5, 6, 7, 8. So current passing through the ammeter here through the iron spoke is 0.8 amperes. Then how much voltage is there here? 3 volts. So by looking at the voltmeter and ammeter, let us note down the readings here. V equal to 3 volts, I equal to 0.8 volts. That means through the iron spoke 0.8 amperes current is passing. Then some voltage will get developed across its two ends. How much voltage has been developed here? It is 3 volts voltage has come here. Okay, so let us note down these values again in the table here. Second time, serial number 2, potential difference we got 3 volts, current passing through the iron spoke is 0.8 amperes. I will calculate V by I values later. Next, this time I am going to take 3 batteries, that is 3 dry cells I have connected in series. isn't it? So let us connect the same circuit. Again, I am closing the key here. Now you see here how much current is passing through the iron spoke, means here it 1.1, 1.2 amperes, and here voltage is 4.245. So 4.5 volts. So let us note down the readings here. Current is 1.2 amperes, voltage is 4.5 amperes. Let us note down these readings here in the table. 3, 4.5 volts, 1.2 amperes. Next, now I will connect 4 dry cells in series. You see here. Okay, so let us close the key here. Then you can see here. Here 1.5, 1.6 ampere current is passing through the iron spoke. Then voltage developed across the two ends. Okay, between the two ends is 6 volts. So current equal to 1.6 amperes and voltage equal to 6 volts. V equal to 6 volts, I equal to 1.6 amperes. Let us note down these readings in the table. Fourth case, 6 volts, 1.6 amperes. Next, I will connect 5 dry cells. This time I am taking all the dry cells together. Let us connect in the same way. Close the key. See here. Here, how much current is passing through the iron spoke, means here it is 2 amperes. And here 6.5, 6.2, here 7 is there, 7.2, 7.4, 7.5 volts. Okay, so current passing through the iron spoke is 2 amperes and voltage developed across its terminals, its ends, is 7.5 volts. Okay, so here V equal to 7.5 volts, I equal to 2 amperes. So let us note down these readings again in the table. 5, 7.5 volts, 2 amperes. So these are the readings, observations I have taken from the above circuits. Okay, now I am going to calculate V by I value in each case. See here, in the first case voltage is 1.5 volts, that is the potential difference is 1.5 volts and current is 0.4 amperes. Let us calculate V by I value in each case. So here 1.5 is the voltage, I is 0.4, 1.5 divided by 0.4 equal to 3.75. The second case 3 by 0.8, again we got 3.75. 4.5 divided by 1.2 we get 3.75. Here 6 by 1.6, again we got 3.75. Here also 3.75. So by looking at this table here, in the last column of the table, that is V by I values are same in each case. That means V by I is constant. Okay, so V by I is constant. Let us see here. What do we notice from the above table? See here, the ratio V by I is a constant. This constant is called as the resistance of the iron spoke. Okay, so we can conclude here V by I is constant. That constant is nothing but R. R is called as the resistance of the iron spoke. That means when current increases, voltage also increases. Current decreases, voltage also decreases. However, the ratio V by I is always constant. That constant is called as the resistance of the iron spoke in this case. So we can write this mathematically as V is directly proportional to I. This is called as the Ohm's law. Isn't it? You see here? From this experiment, we can conclude that the potential difference between the ends of the iron spoke, that is conductor, is directly proportional to the current passing through it. That means when more current passes through the conductor, then more potential difference will get across the ends. Okay, so this is called as the Ohm's law, isn't it? Now let us draw a graph between V and I. Taking V on the x-axis, I on the y-axis, let us draw the graph. See here, this is a graph paper. Here I am drawing one horizontal line, that is x-axis, and here is the vertical line. This line shows the y-axis. On x-axis, I am taking voltage in volts. On y-axis, I am taking I, that is current in amperes. So see here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 8 only. So here 0 0.5, 1.0, 1.5, 2.0, 2.5. Okay. See here, by taking voltage on the x-axis and current on the y-axis, here I am drawing the graph. So let us bring back the table here. So first we should know the scale also. On the x-axis, 1 centimeter, that is from here to here, 1 centimeter has been taken as 1 volt. That means 1 millimeter, that is 1 centimeter. Between this 1 centimeter length, small boxes are there. They are millimeter, okay, boxes. So here 1 millimeter equal to 0.1 volts. So this is the scale for x-axis. Next, the scale for y-axis is 1 centimeter length. I am taking it as 0.5 amperes. That means 0.5 divided by 10. 10 boxes are there. 10 divisions are there. Means you will get 0.05 amperes. That means 1 millimeter equal to 0.05 amperes on the y-axis, whereas 1 millimeter equal to 0.1 volts on the x-axis. Isn't it? Now let us bring back the values we got so far. See here. For 1.5 volts, what is the current? 0.4 amperes. 1.5 volts means here 1, here is 1.5, and the current is 0.4 amperes. 0.4 amperes means 0.4 divided by 0.05, because one small unit represents 0.05 amperes. So 0.4 divided by 0.05 means we get 8 units. So that means here 1.5, here 5, 6, 7, 8. Here I am placing the point here. That's all. Okay, so 1.5 volts, here 0.8 amperes current. Next, again 3 volts. For 3 volts, what is the current here? 0.8 amperes. So 3 volts means here 0.8. We have to count 0.8 means 0.8 divided by 0.05. Isn't it? So 0.8 divided by 0.05 means we get 16. 16 divisions we have to show. 3 volts here, here 10, 15, 16 divisions here. That's all. Similarly, 4.5 volts here. Here it is 1.2 amperes. 1.2 divided by 0.05. 24 divisions we have to show. So 4.5 volts here. Here 20, 24 divisions here. 1.2. That's all. 24 divisions. Next, 6 volts, 1.6 amperes. 6 volts, 1.6 divided by 0.05. 32 units we have to show. So here up to here 30, 30, 31, 32 here. That's all. Next, serial number 5, 7.5 volts. For 7.5 volts, current is 2 amperes. Directly here, it is 2 amperes. That's all. 7.5, 2 amperes. Now, let us connect all these points. We get a straight line. So this graph is called as the VI graph. And in case of the conductors which obey the Ohm's law, the VI graph is a straight line passing through the origin. Okay? The slope of this graph gives the resistance of the iron spoke in this case. If you find slope, that is V by I, we get here. Okay, so this is all about Ohm's law. Thank you.